Hi friends, today we are going to learn about the full-wave rectifier using a center-tapped transformer with two diodes and the role of a capacitor in filtering AC ripples. What is a full-wave rectifier? A rectifier is a circuit that converts AC, alternating current, into DC, direct current. A full-wave rectifier allows both the positive and negative halves of the AC cycle to be converted into DC, making it more efficient than a half-wave rectifier. There are two types of full-wave rectifiers. Using a center-tapped transformer and two diodes, which we are discussing today. Using a bridge rectifier with four diodes. A center-tapped transformer has a secondary winding with a middle connection, center tap. This center tap acts as a reference ground, splitting the AC voltage into two equal halves. In this circuit, two diodes D1 and D2 are used to rectify both halves of the AC signal. The center tap is treated as ground. The output voltage is taken across the load resistor connected between the center tap and the rectifier output. Working of the center-tapped full-wave rectifier. The AC input signal goes through two cycles. 1. Positive half cycle. The upper half of the transformer's winding is positive, and the lower half is negative. D1 is forward biased and conducts current. D2 is reverse biased and does not conduct. Current flows from the upper winding, through D1, across the load resistor, and back to the center tap. This produces a positive voltage across the load. 2. Negative half cycle. The lower half of the transformer's winding is now positive, and the upper half is negative. D2 is forward biased and conducts current. D1 is reverse biased and does not conduct. Current flows from the lower winding, through D2, across the load resistor, and back to the center tap. This again produces a positive voltage across the load. Thus, both halves of the AC cycle are used to generate continuous pulses of DC voltage. Why do we need a capacitor? Although the rectifier converts AC to DC, the output is not a smooth DC voltage. Instead, it consists of pulsating DC with ripples. These ripples can cause unwanted fluctuations in electronic circuits. A capacitor is used as a filter to smooth out these ripples. It works in the following way. When the rectifier output is at its peak, the capacitor charges up. When the rectifier output drops, the capacitor discharges slowly, maintaining a steady voltage. This reduces the variation in voltage and makes the DC output smoother. Final output after filtering. With the capacitor in place, the output becomes steady DC voltage with minimal ripples. The capacitor acts as a storage device, supplying current when the rectified voltage dips and ensuring a constant voltage level. Summary. A full-wave rectifier using two diodes works with a center-tapped transformer to convert AC to pulsating DC. D1 and D2 conduct alternately, ensuring that both halves of the AC waveform contribute to the output. A capacitor filter helps remove AC ripples, providing smooth DC voltage. This setup is widely used in power supplies for electronic circuits. That's it for today's explanation. I hope you found it useful. Stay curious and keep learning.